to study the properties of
A.
an acid HCl by its reaction with litmus solution blue and red, zinc metal, solid sodium carbonate,
B.
a base NaOH by its reaction with litmus solution blue and red, zinc metal, hydrochloric acid. Hydrochloric acid turns blue litmus red while it does not affect red litmus. Sodium hydroxide NaOH turns red litmus blue while blue litmus remains unchanged. Hydrochloric acid reacts with zinc metal to produce hydrogen gas. Solid Zn plus aqueous 2HCl gives aqueous ZnCl2 plus gaseous H2. Hydrogen gas burns with a pop when a burning candle is brought in contact with it. Gaseous 2H2 plus gaseous O2 gives liquid 2H2O. Hydrochloric acid reacts with sodium carbonate to produce carbon dioxide. Solid Na2CO3 plus aqueous 2HCl gives aqueous 2NaCl plus liquid H2O plus gaseous CO2. Carbon dioxide gas turns lime water CaOH twice milky. Aqueous CaOH twice plus gaseous CO2 gives solid CaCO3 plus liquid H2O. Zinc metal reacts with sodium hydroxide solution to form sodium zincate and hydrogen gas. Solid Zn plus aqueous 2NaOH gives aqueous Na2ZnO2 gaseous H2. Sodium hydroxide is a base. It neutralizes hydrochloric acid solution to produce sodium chloride, common salt and water. Aqueous HCl plus aqueous NaOH gives aqueous NaCl plus liquid H2O.
Ma'am, how can we study the difference in the properties of HCl and NaOH?
Hydrochloric acid turns blue litmus red while it does not affect red litmus. Sodium hydroxide NaOH turns red litmus blue while blue litmus remains unchanged. Let's do an experiment to study the properties of
A.
an acid HCl by its reaction with litmus solution blue and red, zinc metal, solid sodium carbonate.
B.
A base NaOH by its reaction with litmus solution blue and red, zinc metal, hydrochloric acid. Our aim is to study the properties of
A.
an acid HCl by its reaction with litmus solution blue and red, zinc metal, solid sodium carbonate. The materials required are test tube stands, a dropper or a glass rod, litmus solutions blue and red, hydrochloric acid, zinc metal, sodium carbonate, soap solution, candle, flat-bottomed flask, beaker, water and delivery tube. Procedure and observations. With litmus solution. Experiment. Take 2 ml of blue litmus solution in a test tube and add a few drops of hydrochloric acid HCl to it. Shake the solution. Observation. Blue litmus turns red. Take 2 ml of red litmus solution in a test tube and add few drops of HCl to it. Shake the solution. Red litmus remains unchanged. Inference. HCl is acidic in nature. With zinc metal. Experiment. Take about 5 ml of dilute HCl in a test tube. Add a few pieces of zinc granules to it. Observation. Some gas bubbles are formed on the surface of zinc granules. Pass the evolved gas through the soap solution. Soap bubbles are formed which rise up and burst when a candle is brought near them. Bring a burning candle near a gas-filled soap bubble. Candle is extinguished and gas burns with a pop sound. Inference: the gas produced is hydrogen. With sodium carbonate. Experiment: take a small amount of sodium carbonate Na2CO3 in a flat-bottomed flask. Add about 3 ml of dilute HCl to it. Observation: CO2 is produced within effervescence, a rapid evolution of gas. Pass this gas through lime water. Lime water turns milky. Inference: the gas produced is CO2. Result: hydrochloric acid HCl turns blue litmus red, while red litmus remains unchanged. HCl reacts with zinc metal and produces H2 gas. HCl reacts with sodium carbonate and produces carbon dioxide gas. Hydrochloric acid is acidic in nature. Precautions: use clean zinc granules. Cover zinc metal completely in HCl solution. Always carry out the test for hydrogen with a very small volume of gas. Handle hydrochloric acid carefully because it can burn skin and clothes. Shake the solutions without spilling them. B. A base NaOH by its reaction with litmus solution blue and red, zinc metal, hydrochloric acid. Our aim is to study the properties of B. A base NaOH by its reaction with litmus solution blue and red, zinc metal, hydrochloric acid. The materials required are test tubes, litmus solution blue and red, dilute NaOH solution, phenolphthalein solution, flat-bottomed flask, beaker, dilute HCl solution, zinc metal and dropper. Procedure and observations. With litmus solution. Experiment: take 2 ml of red litmus solution in a test tube and add few drops of dilute sodium hydroxide NaOH to it. Shake the solution. Observation: red litmus turns blue. Inference: NaOH is basic in nature. Take 2 ml of blue litmus solution in a test tube and add few drops of NaOH to it. Shake the solution. Color of blue litmus remains unchanged. NaOH does not affect blue litmus, therefore it is a base. With zinc metal. Experiment: place a few pieces of granulated zinc metal in a test tube and add 2 ml of sodium hydroxide solution. Set up the experiment. Observation: some gas bubbles are formed on the surface of zinc granules. Inference: zinc reacts with the NaOH and produces gas. Pass the evolved gas through the soap solution. Bring a burning candle near a gas-filled soap bubble. Gas burns with a pop sound. Gas produced is hydrogen. With hydrochloric acid. Experiment: take some amount of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. Observation: the color of the solution is pink. Inference: NaOH is alkali. Add dilute HCl solution drop by drop to the above solution. Pink color disappears. The effect of base NaOH is nullified by an acid HCl and vice versa. Add a few drops of NaOH to the above solution. The pink color of phenolphthalein reappears. Result: dilute NaOH turns red litmus blue, but it does not affect blue litmus. It shows that sodium hydroxide is a base. Sodium hydroxide reacts with zinc metal and produces hydrogen gas along with the formation of sodium zincate. The effect of NaOH, a base, is nullified by HCl, an acid, and vice versa, as H positive ion of acid react with OH negative ion of base to form neutral water. Precautions. Use clean zinc granules. Cover zinc granules completely in NaOH solution. Handle sodium hydroxide solution carefully.
Thank you, ma'am. We have understood the experiment very well.